Hi, welcome guys. Today we are going to take some statistics questions with guided solutions. Note that the questions we'll be solving today are selected trial questions from books such as Blumen, Complete Guide to Statistics, Naked Statistics, Statistics for Business and Econs, and other related books. So without wasting much time, let's start. Let's take the first question. Question 1 says, data that can be classified according to color are measured on dash scale. When you classify data according to color, for instance, hair color, eye color, t-shirt color, and the likes, then it will be on nominal scale of measurement. Okay, so the correct answer to question 1 is option A, nominal scale of measurement. So let's proceed to the next question. Which of these data is qualitative? Remember, we have qualitative data and quantitative. The quantitative are the ones in numerals, they are in numbers. But the qualitative are in quality, not in numerals. Okay. Let's look at the option D, which is nationality of footballers. Some are Ghanaians, some are Ivorians, some are Cameroonians, and the likes. You see that their nationality is not in numeral, but rather in a particular quality. Hence, the nationality of footballers is a qualitative data. So, the correct answer to question 2 is option D, nationality of footballers. So, let's proceed to the next question. In a study of reaction time to a specific stimulus, a psychologist recorded these data in seconds. Use the frequency distribution table below to answer question 3 to 9. Question 3 says, what is the class width for the frequency distribution table? To find class width, this is how we do it. We are going to find the difference between the lower class of the first class and the lower class of the second class. So that is the first class, the lower class limit of the first class is 2.1. And the lower class limit of the second class is 2.8. So what is the difference? 2.8 minus 2.1 will give you what? It will give you 0.7. Okay, so the correct answer to this question is option D, which is 0.7. Remember, class width is the lower of the first class and the lower of the second class, the difference. Okay, also, if you take the lower of the second class and that of the third class, and you find their difference, you still get that same 0.7. So this is how to find class width. Then let's look at the next question. This question says, what is the class size for frequency distribution table? It is important to be able to distinguish between class width and class size. Most times when they ask students to find class width, they usually find class size thinking they are finding class width. To find class size, you can just be in the first class and find the difference between the upper class limit and the lower class limit of that same class. Let's take the first class for instance. When we take the upper and the lower and we find the difference, that is 2.7 minus 2.1, we get 0.6. If you go to the second class and you do same, 3.4 minus 2.8, you get that same 0.6. Go to the third class, 4.1 minus 3.5, you get that same 0.6. So the class size is just the difference between the upper class limit and the lower class limit. So do not mistake this for class width anymore. Okay. So the correct answer to this particular question is C, 0.6. The class width is 0.7 and the class size is 0.6. So let's proceed to the next question. Question 5. Find a class mark for the class 4.2 to 4.8. To find class mark for any class, you have to add the upper class and the lower class of that class and divide it by 2. So we are finding the class mark for the class 4.2 to 4.8. So to get it, we say 4.2 plus 4.8 all divided by 2. So 4.2 plus 4.8 will give you what? 9, isn't it? Then divide it by 2. You get 4.5. So the correct answer to question 5 is B, 4.5. Whenever they ask you to find class mark, you take the upper class and the lower class of that class, add them together, and divide the result by 2. That will give you the class mark. The next question says, find a class boundary for the class 2.1 to 2.7. Now, before you can find class boundary, you need a particular constant that we are going to rob from Peter to pay Paul. This is how we do it. Now, we are going to take the lower class of the second class and the upper class of the first class and find the difference between them and divide it by 2. So in this case, I'll take 2.8 and 2.7. So 2.8 minus 2.7 will give you 0.1. So divide that 0.1 by 2. You'll get 0.05. Now, this 0.05, this is how we are going to use it to get a class boundary. Pay attention. You were asked to find a class boundary for the class 2.1 to 2.7, isn't it? So 2.1 is the lower class limit, isn't it? And 2.7 is the upper class limit. So let's say 2.1 is Peter and 2.7 is Paul. Now you see the 0.05, we're going to rob it from Peter, which is the lower class, and pay it to Paul, which is the upper class. So let's rob the 0.05 from Peter. So to rob it, that will be what? 2.1 minus, because we are robbing, we are taking away from Peter. So 2.1 minus 0.05, that will give us 2.05. So that 0.05, let's give it to Paul. That's the upper class. So that will be 2.7 plus, we are given, so we have to add to Paul, you get it. So 2.7 plus 0.05, and that will give you 2.75. So you say the class boundary is 2.05 to 2.75. So the correct answer to this particular question is option D, 2.05 to 2.75. So let's proceed to the next question. This question says, what is the cumulative frequency for the class 2.8 to 3.4? To find the cumulative frequency for the second class, which is class 2.8 to 3.4, this is what we are going to do. We are going to add all frequencies from the beginning up to the class we are finding its cumulative frequency. So we are finding the cumulative frequency for the second class, isn't it? So to get a cumulative frequency for the second class, you need to take from the first class up to the second class and add them together. So that will be 12 plus 13. Okay. If you were finding for the third class, that's 3.5 to 4.1. It will be 12 plus 13 plus 7. For the next one too, it will go in that manner. Okay. So since we are finding for 2.8 to 3.4, it will just be 12 plus 13. And that will give us what? 25. So the correct answer to question 7 is C, 25. So let's proceed to the next question. This question says, find the relative frequency for the class 4.9 to 5.5. To find the relative frequency of a particular class, you need to take the frequency of that class and divide it by the total frequency. So this means that we need to know what the total frequency is first. So let's find the total frequency first. 12 plus 13 is 25, plus 7, that's 32, plus 5, that's 37, plus 2, that's 39, plus 1, that's 40. So the total frequency is 40. To get the relative frequency of that particular class, which is class 4.9 to 5.5, we need to take the frequency of that class. So in this particular table, what's the frequency of 4.9 to 5.5? It's 2, isn't it? So we take 2 divided by 40. When you take 2 over 40, you get 1 over 20, which will give you 0.05. Then let's proceed to the next question. This question says, find the cumulative relative frequency for the class 2.8 to 3.4. Please look at this question carefully. We solved a question which asked us for cumulative frequency, and we also solved a question asking for relative frequency. But this particular question is asking for cumulative relative frequency. Remember that the total frequency is 40. Okay, so to find cumulative relative frequency, we are going to take the cumulative frequency of that class. I didn't say the frequency of that class, no. I said the cumulative frequency of that class because we are finding cumulative relative frequency. So we take the cumulative frequency of that class and divide it by total frequency to get cumulative relative frequency. So we are looking for class 2.8 to 3.4, isn't it? Now, what is the cumulative frequency of class 2.8 to 3.4? That will be 12 plus 13, isn't it? So that will give you 25. So we take 25 divided by total frequency. So 25 divided by 40 will give you 0.625. That's option D. So the correct answer to this is 0.625. So let's proceed to the next question. This question says, except for rounding errors, relative frequency should sum up to. Now, this is what this means. Let me recall the table we used in the previous question, which is this table. Now, we were given classes and their frequencies, isn't it? So let's find a relative frequency for each class. So for the first class, that will be 12 over 40. For the second class, that will be 13 over 40. Third class will be 7 over 40 going. So this is what it will give us. The first one is 0.3, second one is 0.325, and the like. If you add all the relative frequencies together, it is a must to get a 1. If there is no rounding error, so the correct answer to this particular question is B, okay, which is 1. So let's proceed to the next question. This question says, a statement is made that the average distance from the mean in a set of values is 10. Which measure is being used here? When we find the average distance from the mean, then we say it is the mean absolute deviation. And this is the formula. You see the x minus mu. The mu stands for mean, okay? X minus mean is called deviation. Now you see the two lines that the deviation is between, okay? Those two lines, we call them absolute, okay? Absolute value of something. Let's say absolute value of negative 2 give you positive 2. So absolute deviation. Now, summation of absolute deviations divided by n should give you the average absolute deviation. And average is mean. So it's mean absolute deviation. So the correct answer to question 11 is C. Okay. So let's proceed to the next question. This question says, when it is necessary to determine whether an observation from a set of data falls in the upper 25% or the lower 75% of the ordered data set, which measure should be used? To understand this question, let me draw this for you. Now look at this. This is the upper 25%. And this is the lower 75%. Let's say this is an entire data. Okay, the box, the full box is an entire data. Now, if you should divide it at this point, where the line is within the box, the upper 25% is your what? Your right, isn't it? And the lower 75% will be your left. You see the line you've used in cutting the upper 25% and the lower 75%. That will be the Q3, okay, third quartile. Now, let me show you another box. This, for instance, you see that the 25% is a lower. Lower means your left. Upper means your right. Okay, so you have 75% right and 25% left, which is lower. So for the line over here, you need to find first quartile to know that. To determine whether an observation falls in the upper 25% or the lower 75%, you need to find a third quartile. But to determine whether an observation falls in the lower 25% and upper 75%, you need to find a first quartile. First quartile is also known as lower quartile. And third quartile is also called upper quartile. Okay. So the correct answer to this particular question is option C, which is third quartile. So let's proceed to the next question. This question says, a study that involves no researcher intervention it is called observational study. Okay, you only record what you've seen, you don't intervene. Okay, you record what you've seen. So it doesn't need the intervention of the researcher. The researcher only record what he or she has seen. So it is observational study. Okay, so let's proceed to the next question. This question says, which is not part of the five numbers summary? You were taught box plot, isn't it? In the box plot, you have the minimum data value, you have the maximum data value, you have the first quartile, you have the second quartile, and you also have the third quartile. Remember, second quartile is also known as the median. So you see that in the box plot, you don't have the mean. So the mean is not part of the five number summary. So the five number summary are the first quartile, which is Q1, the third quartile, which is Q3, the median, which is Q2 or second quartile, the smallest, which is the minimum, and the largest data value, which is the maximum. So those are the five number summary. Okay, so let's proceed to the next question. This question says, when statisticians wish to see if there is a relationship between two variables, the most appropriate type of graph to use will be a. Now, if you are studying the relationship between two variables, okay, you are going to draw something called the scatter plot. Okay, you draw the scatter plot. So this is a scatter plot of output versus input. I want to know the relationship that exists between output and input, which are two different variables. They both vary. They are not constant. They are variables. Input can vary. Output can also vary. So they are variables. So I want to study the relationship between those two variables. Okay. So this is a positive relationship, upward movement. You see that? So it is a scatter plot that we use. Option C. Is that clear? Option C. Okay. So let's proceed to the next question. This question says, what graph should be used to show the relationship between the parts and the whole? So this is the graph we use. So this is used to show the relationship between the parts and the whole. Okay, so we call it a pie chart. So let's proceed to the next question. This question says, a survey of 500 freshmen in KNUST found that 95% did not get their first choice programs. The 95% represents a, you know that all freshmen in KNUST is actually more than 500. So all freshmen in KNUST is a population of freshmen. But you see the survey of 500, that 500 that were surveyed is just a sample. So 500 is a sample. Okay. And it says, found that 95% did not get their first choice program. The 95% is just characterizing the sample of 500 freshmen in KNUST. It's not characterizing the entire population of freshmen. It's only describing the sample, not the entire population of freshmen, but just the sample of 500 freshmen. You say that 95% is a statistic. There's no S at the end. Please, not statistics, but statistic. If the 95% were characterizing the entire population, that one you would have said is a parameter. But in this particular case, the 95% is just characterizing or describing the sample of 500 freshmen in KNUST. So for that matter, the 95% is a statistic. So the correct answer for this is D. Okay, so let's proceed to the next question. At an outpatient testing center, the number of cardiograms performed each day for 20 days is shown in a given graph. Use the stem and leaf plot given to answer questions 18 to 23. So question 18 says compute the mean. Let's write the numbers in the stem and leaf one after the other. So on the first row, you have 0, 2. So you write 0, 2. When you go to the second row, you have 1, 3, 1, 4, 2, 0, 2, 3, 2, 5. So you'll be taking the stem and be merging it with each of the leaves. Okay. So when you go to the fourth row, you have 3 over there. The stem is 3. So first you take 31, then you take 32 next, 32 again, 32, 3, 2 again, then 3, 3, 3, 6. Then you do that to the last. So that's what I've written down here. So I've separated them using comma. So you can do the same. Now to compute the mean, anytime a question says compute the mean without specifying the type of mean you should compute, just compute the arithmetic mean. Remember, we have different types of mean. You have arithmetic mean, you have geometric mean, you have harmonic mean, you have trimmed mean, okay, and the like. But when a question doesn't specify the type of mean you should compute, it is basically asking for the arithmetic mean, which is the average, okay. So to find the arithmetic mean, you add all the values in the data set together and divide it by the number of values in the data set. When you add all the values in the data set, add them and see 2 plus 13. Please, 0, 2 is the same as 2. Okay. 2 plus 13 plus 14 plus 20 plus 23 going. Add everything. You get 661. Okay. Then count the number of values in the data set. Count them one after the other. You get 20 values. Okay. So to compute the arithmetic mean, it should be 661 divided by 20. So when you divide 661 by 20, you get 33.05, which is option A. Okay. So the correct answer to this is 33.05. So let's proceed to the next question. This question says, find the median. To find the median, let's list the data values again. Okay, so I've listed them. Now to find the median, it means you should find the middle value. Now to find the median, this is what I'm going to do. Let me cancel 1, 2, 3, 4, 5, 6 from the front here. Okay, I've cancelled 6 values. And then from the back, let me cancel 6 also. 1, 2, 3, 4, 5, 6. So I've cancelled 6. I want to cancel till I get a middle number. Okay, I think I can cancel some extra 3 more. So let me cancel some extra 3 at the right. So I've cancelled them, and let me cancel some extra 3 from the left. So I'll be left with 2 values at the middle. That is 32 and 32. Okay. If it were 1 value left at the middle, you consider that 1 value as a median. But if there are 2, okay, you add the 2 of them together and divide it by 2. So check. 32 plus 32 will give you 64. Divided by 2, you get 32. So the correct answer to this is 32. The median is 32. Okay. So let's proceed to the next question. 20 says, what is the mode for the data set? The mode means the number that occurs the most. So when you check through this properly, you realize that 32 occurs 4 times and no other value occurs up to 4 times. So because 32 occurs 4 times and no other value occurs up to 4 times, then we say 32 is the mode. Okay. So the correct answer to this is 32 also. The mode is 32. Okay. So let's proceed to the next question. This question says, find the first quartile. Please pay attention over here. Remember that when we were finding the median was between these last two 32. And when we found the exact median, it was also 32. So which is between the two 32 here. So I've placed it between them. So to find the first quartile, you take all those values that are at the left of the median. So let me take them. These are the values at the left of the median. So when you take the values at the left of the median, then you find their median too. You find the median of those values at the left of the original median. Okay. So to get their median, you realize that these 2 values will be at the middle.
when you count 1, 2, 3, 4, 1, 2, 3, 4, these two values will be at the middle, 23 and 25, isn't it?
But we can't take the 2. We have to add them together and divide by 2. So 23 plus 25 will give you what? 48. 48 divided by 2 will give you 24.
So the median of those values at the left of the original median will be the first quartile. So the correct answer to this is C. Let's look at the next question.
This question says we should find the third quartile. Now, to find the third quartile, you also take those values at the right of the median.
So let's take those values at the right and find their median too. Now, in an attempt to find their median also, it will fall between two values, which is 44 and 44. So add 44 and 44 together and divide it by 2. So 44 plus 44 is 88. Divided by 2, you get 44 again. So the median of those values at the right will be the third quartile, so which is option B, 44. Okay. Now let's proceed to the next question.
This question says, compute the interquartile range. To find interquartile range should be third quartile minus first quartile, or upper quartile minus lower quartile. Remember the lower quartile, which is first quartile, to be what? 24. And we also got the upper quartile, which is third quartile, to be what? 44. So find the difference. 44 minus 24 will give you what? 20. So that means the interquartile range is 20. So let's proceed to the next question. This question says, the number of ads on a 1-hour TV show is what type of data? It is a quantitative data. But remember, quantitative data is divided into 2. We have discrete and continuous. So the answer is between B and C. They want a specific answer to it. Let me remind you of something. Both discrete and continuous are quantitative. The discrete are the ones you can easily counting, okay, to get a numeral. But a continuous one, you don't count to get a numeral. Rather, you measure to get a numeral. The number of pizza sold by Pizza Man on KNUST campus yesterday is discrete because you can count the number of pizza. 1, 2, 3, 4. You see that? But if you want to know the weight of pizza sold to KNUST students yesterday by Pizza Man, the weight, do you count the weight of a pizza? No, you measure it using an instrument, isn't it? So because you measure the weight is continuous. But the number of pizza itself is discrete. But the weight of pizza, the weight, is continuous. So the number of ads, you can count the number of ads. So because you can count the number of ads, you say it is discrete data. So let's proceed to the next question. This question says, a researcher divided subjects into 2 groups according to gender and then selected members from each group for her sample. What sampling method was the researcher using? Whenever you divide into group of similar characteristics, example gender, male and female, and you select a sample from each group using simple random sampling, then that's going to be a stratified sampling technique. You can check the playlist of this channel to watch a video on sampling technique. There you know the difference between simple random, systematic, stratified, and cluster sampling technique properly. Okay, but for this particular one, the answer is option C, stratified. Okay, so let's proceed to the next question. This question says, the number of deciles in any data set is, let me draw a rectangle and divide the rectangle into 10 equal parts. So I've divided it into 10 equal parts. Now let's count the lines within. Okay, the lines within that I've used in dividing them. Let's count the lines. So let's count it. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9.
I started counting from here. You see that? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one, the answer will be 9. The number of decimals in any data set is 9. Okay, let's proceed.
The sum of the deviation about the mean for the data set 6, 8, 10, 2, and 4 is always.
Now, what this question means is, let me write this data set in tabular form. So I have this x, 6, 8, 10, 2, 4. Now, let me find their deviation.
I need to know the mean first. So the mean will be summation of the values divided by the number of values, isn't it? So 6 plus 8 is 14, plus 10 is 24, plus 2 is 26, plus 4 is 30. Then we divide it by their number. How many are they? 1, 2, 3, 4, 5. So 30 divided by 5 will give you 6. So the mean is 6. So let's find deviation. To find deviation, we are going to take each data value and subtract the mean from it. So this is it. 6 minus the mean. The mean is 6, remember. 6 minus 6 will give you 0. 6 minus 6 will give you 2. 10 minus 6 is 4. 2 minus 6 is negative 4. And 4 minus 6 is negative 2. So these are deviations. Now, add all the deviations together. 0 plus 2 plus 4 plus negative 4 plus negative 2. Add them together. What do you get? You would definitely get a 0. Now, whenever you see a question like this, asking for the sum of deviation about the mean, no matter how large the data set is, do not worry yourself doing any calculation. Just pick 0. The answer would definitely be 0. Don't worry yourself computing anything. When they ask you for the sum of deviation about the mean for the data set, they might give you any data set. Don't worry yourself doing any calculation. The answer is 0. They are asking for the sum of deviation. This is the key word. Deviation about the mean. Okay. So the sum of deviation about the mean is 0. Okay. So let's proceed to the next question. This question says, what are the boundaries for 8.6 to 8.8? Now, let's write 8.6 to 8.8. Then you ask, what value comes before 8.6? It was supposed to be something like 8.5, isn't it? The 8.6 to 8.8, the size will be 0.2. So you need to create something such that it also has the size of 0.2 at the top. So that should be something like 8.3 to 8.5. The size will also be 0.2, isn't it? 8.5 minus 8.3, that's 0.2. 8.8 minus 8.6, that's also 0.2. You see that? And 8.5 comes before 8.6, isn't it? Now let's find the constants we are going to rub from Peter to pay Paul. I hope you remember this. So to find that value, we take 8.6 minus 8.5, that will give us 0.1, isn't it? And divide it by 2, we get 0.05, isn't it? So that 0.05, we're going to rub it from Peter and give it to Paul. So Peter is 8.6 and Paul is what? 8.8. So 8.6 minus 0.05 will give you what? 8.55, isn't it? Then let's add it to Paul. 8.8 plus 0.05 will give you what? 8.85, isn't it? So the correct answer to this is option A. 8.55 to 8.85. That's the correct answer. So let's proceed to the next question. This question says, a variable that interferes with other variable in a study is called a confounding variable. Okay, it's called a confounding variable. Question 30. If a distribution has a zero variance, which of the following is true? Now, when you have a data set like this, 7, 7, 7, 7, 7, like that, and they ask you to find the mean will still be 7. You try it and see. Add all the values together and divide it by the number of values. You will definitely get 7 back. But if you should find the variance will give you 0, and the standard deviation will also give you 0. So if you have constant data set, the variance must be 0, and the standard deviation must be 0 too, and the coefficient of variation will also be 0%. If you find the mean, you get the same thing as the mean, the same 5 as the mean. But if you find the variance and standard deviation, you definitely get 0, and the coefficient of variation will be 0%. If you have this, the mean will still remain A, but the variance and the standard deviation will be 0. So this question is saying that if a distribution has 0 variance, which of the following is true? When all the values are equal to each other, like the case you have here, then the variance will be 0. Let's proceed to the next question. This question says, what is another name for the guys? Look at this. This is how the guys curve looks like. And another name for it is cumulative frequency graph. So let's proceed to the next question. This question says, what is the value of the mode when all values in the data set are different? For example, when you have this 7, 17, 24, 5, 8, and 14, you can see that all the values in the data set are different. When you have these two, 20 Ghana cedis, 39 Ghana cedis, 25 Ghana cedis, and 37 Ghana cedis, you see that all the values are different. In this case, you have to say there is no mode. Please don't say the mode is 0. 0 can also be a data value. So do not say the mode is 0. It will be wrong when you say the mode is 0. You have to say there is no mode. Then let's proceed to the next question. Question 33 says, 250 corresponds to, 250 is called 50th percentile. Okay, take this note. In every data set, Q1, which is first quartile, must be equal to 2.5 decile. And it must also be equal to 25th percentile. Also, in every data set, the second quartile, which is Q2, must be equal to the 5th decile. It must also be equal to the 50th percentile. And third quartile, which is Q3, must be equal to the 7.5 decile, and it must also be equal to the 75th percentile. So, this question is saying that 50th percentile corresponds to, it should correspond to the second quartile or the median. It should also correspond to the 5th decile. So the correct answer is 5th decile. This question says, when data are first collected, they are called, the answer is primary data. Okay. And primary data is also referred to as raw data. Okay. So the correct answer for this is option D, raw data. So let's proceed to the next one. This question says, when data are categorized as, for example, places of residence, rural, suburban, urban, the most appropriate measure of central tendency is, this is a nominal level data. For nominal level data, the best measure for it should be the mode. Okay, so the correct answer to this is option D. The best measure for nominal level data is the mode. So let's proceed to the next question. Use a box plot given to answer question 36 and 37. Question 36 says, find the interquartile range. It's important to understand that this is the minimum value, this is the maximum, the 65 is the maximum. Then this 40 here is the first quartile, and this 60, the end of the box, the 60, which is the end of the box, is the third quartile. But the one within the box is the second quartile. Now, this question says you should find the interquartile range. Interquartile range should be third quartile minus first quartile. That's Q3 minus Q1. In this case, your third quartile is 60 and your first quartile is 40. So 60 minus 40 will give you what? 20. So for this particular question, the interquartile range is 20, which is option B. Question 37 says, what type of distribution is indicated? Now look at where the second quartile is, which is 55. Now, from 55 to 60 is your right, isn't it? And from 55 to 40 is your left, isn't it? Now let me shade the right. Okay, that's from 55 to 60. And then let me shade the left of the box with a different color. That's 55 to 40. To know the type of distribution, whenever the right is larger than the left, you say it is right skewed. Another name for right skewed is positively skewed. Okay. But when the left is larger than the right, you say it is left skewed. And another name for left skewed is negatively skewed. But when both sides are the same, you say it is symmetric or zero skewed. Okay. For this particular one, the left is bigger than the right, so it is left skewed. So the correct answer is option C, negatively skewed. Remember I said left skewed is the same as negatively skewed, and right skewed is the same as positively skewed. So let's proceed to the next question. This question says, a numerical value used as a summary measure for a sample such as the sample mean is known as, they said for the sample, not for the population. So for the sample, it should be sample statistic, no S at the end of the statistic. Okay, sample statistic. But for the population, it should be population parameter, option A. Okay, so the correct answer to this is option C, sample statistic. So let's proceed to the next question. This question says, a data value is considered to be an outlier if we consider a data value to be an outlier if it is less than first quartile minus 1.5 times interquartile range, if it is more than third quartile plus 1.5 times interquartile range. So please don't choose if it lies between them. No, it is if it is less than Q1 minus 1.5 times interquartile range, or if it is more than 8 plus 1.5 times interquartile range. Okay, so the correct answer to this is option D. Then let's proceed to the next question. A statistic that tells the number of standard deviations a data value is above or below mean is called, look at the keyword, the number of standard deviation. It tells you the number of standard deviation that it is above or below the mean. The correct answer is a z-score. Remember you learned this under Chebyshev theorem and empirical rule. But we are going to learn more about the z-score in normal distribution in second semester. So let's proceed to the next question. This question says, when a distribution is bell-shaped, approximately what percentage of data values will fall within one standard deviation of the mean? The correct answer for this is 68%. This is also under Chebyshev theorem and empirical rule. If the question says, what percentage of your data values will fall within two standard deviations of the mean? That one, the answer will be 95%. If the question says 3 standard deviation of the mean, that one, the answer will be 99.7%. But this particular question says 1 standard deviation of the mean. So the answer is 68%. So I'll end it here for now. You can check the description area below or the comment section for links to statistics trial questions and probability trial questions. Do want to share the link with others so that they can also benefit from this opportunity. Thank you.